Subscribe now and click on the bell icon to never miss learning from Vedantu.
Chalo guys, let's move on now to the limitations of Dalton's atomic theory. चलो इसको मूव कर देता हूं मैं. So that when you get the notes, it is easier for you to simply revise it. ठीक है, चलो. So this is a summary of Dalton's postulates in this weird handwriting that I have, but I believe you guys are making your own notes as well, because that is what will help you eventually when you're revising these chapters. Chalo. Cool. Now, what is happening here is, let us see what are the limitations of Dalton's atomic theory. Now, we are going to look at Dalton's atomic theory through the eyes of a fancy scientist who knows more than Dalton now. Okay? Dheeraj, they are theories. Yeah. Just a minute, let me have some water. So Amrit has given your answer. A theory can be disproved, but a law can't. Although even laws have been disproved, but that's just the game of English, by the way. Yeah. So a theory is a theory. A law is something that is practically applicable to things. Yeah. So Khushagam is saying Amrit is intelligent. All of you are intelligent. So please don't think that one of you is better than the others. Everyone is intelligent. So that is why all of you are even thinking about preparing for IIT JEE, because unless you have that courage in you, unless you have that faith in you that yes, you will clear IIT JEE, so definitely all of you are intelligent. Chalo, badhiya. Ab padhte hain limitations. Now let us look at Dalton's theory from the perspective of a smart scientist. Okay. Now we have to take Dalton's theory, scrutinize it, and give limitations. Chalo. So aage badhte hain. Defining the limitations of Dalton's atomic theory. Okay? So the first thing is, according to Dalton's theory, all hydrogen atoms must have same atomic masses, but the discovery of isotopes. Now someone was asking this question in the chat box. Okay? The point is, isotopes were discovered much later. Mendeleev gave us his periodic table somewhere in the 1860s, as far as I remember. But isotopes were discovered even after that. Okay, so Dalton didn't know about isotopes. All right, and that is why once isotopes were discovered, lots of theories that already existed around atomic masses failed because well, same atoms could have different masses. Yeah. So what are isotopes basically? Guys, can I have some responses in the chat box? What are isotopes? Write down your definitions of isotopes in the... Yeah. Exactly. So basically, isotopes have same atomic number, different atomic mass. Yeah. Same atomic number, but different atomic mass. All right. So all of you know what isotopes are. Awesomeness. Okay. Chalo. So the second limitation is postulate number 3 mein, Mr. Dalton said, we are studying physical chemistry right now. Okay, guys. So again, structure of atom is more about physical chemistry combined with inorganic chemistry. Periodic properties is more about inorganic chemistry. So we are basically studying the bridge of physical and inorganic right now. Okay, it is a mixture of both. Right now, things that are being done are more inorganic in nature. When we move on in this chapter, it will become more mathematical, and that is what technically physical chemistry is all about. But you don't even need to worry about it. study chemistry as chemistry. Okay. Chalo. So, what Dalton had told us is that they combined in fixed ratio of whole numbers. Okay. Yeah. They combine in fixed ratio of whole numbers. That is what Dalton said. But that is not true in the case of non-stoichiometric compounds. This one over here, Fe 0.93O, yeah, is a non-stoichiometric compound. It is not something like NaCl where both the coefficients are 1. It is not something like H2SO4 where you have 2 and 4 whole numbers. No. Non-stoichiometric compounds have non-whole number ratios. Okay, Akash, don't worry, we'll see what these are. First of all, understand that these exist in nature. Okay, stoichiometry. चलो पहले तो मैं stoichiometry का meaning देखते हैं यहाँ पे. The relationship between the relative quantities of substances taking part in a reaction or forming a compound. Typically a ratio of whole integers. Okay, the ratio, the relationship of the ratios is known as stoichiometry. Just a fancy word for proportions. Okay, guys. So this is what stoichiometry means. Okay, so two atoms of hydrogen combined with one atom of oxygen is basically stoichiometry. Okay, so that is all. Chalo, वापस आते हैं. So compounds of different elements are formed, so on and so forth. Whole numbers, in some cases, Yogesh, yes, now we are smarter than Dalton. In some cases, it doesn't happen in whole numbers. It happens in a very non-stoichiometric form. Okay, so we'll see what this is just in a while. Then the third limitation to Dalton's atomic theory is that atom was indivisible. That is what Dalton said. But later on, subatomic particles, particles that are smaller than the atom, were discovered. All right. And then we all know what these particles are. Yes, we know that these main particles are electron, proton, and neutron. Yeah, very simple. Electron, proton, neutron. We've all studied that these exist. Dalton didn't know that. They were not discovered at the time of Dalton. Kanishk, yes, your statement is right. So, point is ki this was another limitation of Dalton's theory because it was discovered later. So, Dalton didn't know. So, we are now smarter than Dalton. Okay, so again, the same limitations are given with examples. Isotopes are elements with same Z but different atomic mass number. Let's see what this one is. So Fe 0.93O is basically a mixture of FeO and Fe2O3. It exists in a solid structure. Okay. Yes. Wait. Chat box खोलने दो. Yes, Arush, you are right. It is from the solid state. Okay. So again, before I tell you this, you will study more about this in solid state chapter. Okay. So don't worry if you don't understand it. You will study this in solid state chapter in detail. But point is, Fe 0.93O is basically a mixture of FeO and Fe2O3. Okay. Here the iron has a +2 oxidation state. Here the iron has a +3 oxidation state. Yeah. So in Fe 0.93O, we may have a small proportion of FeO, yeah, and Fe2O3, which leads to a slight imbalance. And the empirical formula, we all know what empirical is. Empirical is, guys, tell me, what is empirical? We have studied this last week. Yes, Ganesh gave me the first. Yes, experimental. Yes, derived from an experiment. Correct. All of you guys are correct. Empirical means experimental. So when you take that block and do some experiments on it, the empirical formula that you get is Fe 0.93O because it is a mixture of FeO and Fe2O3. Okay. So these individually do not violate the theory, by the way. Yeah. So there are some compounds when they form solid state structures. Okay. And when out of those solid structures you derive their formula, it turns out to be in a non-stoichiometric ratio. ठीक है, it turns out to be a non-stoichiometric formula, not proportional. Yes, and that is why we say that Dalton's atomic theory doesn't fit for everything. Okay, so again, more details about this in the solid state. Okay, but yeah, non-stoichiometric things also exist. Devanit, yes, I am in full screen. Chalo. So subatomic particles were also found later on: electrons, protons, and neutrons. Pretty simple, and very weird diagram of that is also given here. Cool. Chalo. So right now I have a question on the screen for you guys. Please read the question carefully. Try to come up with an answer. Right now the time is 9:56. It is a very easy question. I give you time to read it. Take 1 minute and then I will launch the question in front of you. Don't worry guys, I will launch a poll in front of you so that you can choose the correct answer. Yes, lots of you have the correct answer. I am giving time so that everyone can do this. It's a pretty simple question. So I believe you have read this question till now. Lots of people are giving me answers as well. Yeah, okay. So let us see. Don't worry, guys. Whenever I ask a question, I will give you this in front of your screen. But yeah, most of the people are correct. Okay guys, फटाफट से vote कर दो because I'll close the poll now in 5, 4, 3, 2 and 1. Cool. So majority says C is the answer, 95%. Yes, C is the correct option for this question. Let us see what the question is saying, which is not a basic postulate of Dalton's atomic theory. Okay. First one saying atom is neither created nor destroyed. Yes, Dalton said that. So, this was a part of the Dalton's atomic theory. And Janardhanan is saying he clicked the wrong question. Silly mistakes. Take care of silly mistakes from now on, Janardhanan. Okay? Okay. So, yes, this is correct. Point B is, in a given compound, relative number and kinds of atoms are constant. Yeah, that is what he said. Constant proportions, whole numbers and all that jazz. That is also fine. Point number C, atoms of all elements are alike. This is wrong. We studied the example of hydrogen and carbon. Yeah, hydrogen is different, carbon is different. Therefore, atoms of all elements are not alike. So therefore, since it asks which one is not a postulate, C is the option which is not a postulate of Dalton's atomic theory. If you want to read D, each element is composed of extremely small particles called atoms. This was the very first postulate of Dalton's atomic theory. Yo, cool. तो अब क्या करते हैं कि मैं एक सवाल पूछता हूं आप लोगों से on the screen. Is the concept clear of Dalton's whole atomic theory and the postulates and the limitations of Dalton's atomic theory? Is it all clear? Kushagam. Janardhanan, just wait for 30 more minutes, half an hour more, and then you can have your dinner. Chalo, theek hai, I'll close the poll. Okay, don't worry. For those of you who haven't understood the concept, फटाफट से मैं क्या करता हूँ, ये slide खोल देता हूँ. Dalton said atoms are indestructible. All same type of element atoms are same. Different element atoms are different. They combine in fixed ratios of whole numbers. ठीक है? And in a reaction, atoms are neither created nor destroyed. They are only rearranged. Okay? This is all. Guys, please stop the chat box. Focus on the screen right now. Okay? Okay, we did the limitations as well. Isotopes can't be explained by Dalton's theory. There are non-stoichiometric elements. Guys, please, let's not talk about random things in the chat box. Okay. So non-stoichiometric things are also not explained by Dalton's theory, and electron, proton, neutron, subatomic particles exist, and even those were not explainable by Dalton's atomic theory. Okay, chalo.